when we started deploying our robot in the proof of concepts and users were giving us new use cases, that is when we thought, aha, okay, something is working here. On the one hand, they trust it. So they were saying hi to it every morning. They were saying goodbye every day, for example, at the end of their shift. They dressed it up, for example.
Really?
Yeah, because it reminded them of Sheldon in The Big Bang Theory, so they brought a scarf the day after.
Si parte? Okay. Hi, everyone. Welcome to another chapter of LabcoExist. We're here today in Alto Robotics. It's a company dedicated to the design and productions of robotics or robots for the B2B market. I'm not going to tell you too much because we're going to discover with a wonderful team. Today, we're hosting the conversation, Ciro and me. And we have as the guest from representing Alto Robotics, Sara Bellini, Federico Jaimo, and Giada Francescato. Let's begin, and we're going to have a long conversation, so good luck to all of you. The first thing that we're going to go a little bit more in a high-level kind of way or in a visionary kind of way, and Sara, the first question is basically, what is the vision behind Alto Robotics? Why does it exist?
Okay. Well, the initiative started, first of all, 2.5 years ago with Jody Saglia, who is the CEO of Alto Robotics. Alto Robotics is a venture building initiative. So actually, the first part of the vision comes from the fund that is Saisero, managed by AVM Gestioni, who wanted to invest in a company that was in the field of robotics to push robotics, accelerate robotics in the B2B and then B2C context. So they had the financial vehicle, they just were missing the team and the solution. And Jody was one of the individuals that they spoke to. So he and the fund started building a vision. And at the beginning, the vision was extremely high level. The point was to create a solution very quickly, bring it to the market in about 2.5 years. And at the beginning, actually, the idea was to bring humanoids to the market in 2.5 years. With Jody, at the beginning, this seemed a bit too far-fetched. Not so much in acceptance only, but also technologically speaking, humanoids are very complex. So the vision shifted towards collaborative robotics, service robotics. And then when it hit that point, they started creating the team. And I was brought on board as employee number 1, head of product. And that's where the fun started. So we had this vision of creating a solution that could work with people. But what was the context? How was it to work with people? To do what? Which people? We didn't know.
How did you arrive to that?
The only known way possible as a designer was to apply a design-driven approach. So literally, we went to visit numerous different contexts. From agri-tech, so fields, or hydroponic, serre idroponiche, hydroponic vegetable patches and so forth. We went to hospitals, we went to hotels, looking for the problem to solve.
Wow, so you had a wide range of contexts and sectors you could actually direct your proposition. It was an amazing job. Difficult, though.
Yeah.
Because it was a lot.
Well, it potentially extremely dispersive.
Yeah.
So the part at the beginning was a little troublesome because we had to be very efficient, but then explore. So it was almost a bit of antagonistic at the beginning, and there were only really 2 or 3 of us at the beginning. So we had to also conjugate in a very explorative manner, tie in also the technological part, which instead works really well when you have already an idea of a specification or a requirement. So we had to a bit juggle the two tensions whilst remaining focused on trying to find a business problem to solve and real users. So essentially, we spoke to over 50 decision makers, trying to understand what were the business problems that could be solved with a mobile robot, which as a type of robotic platform, it was the most advanced and most, let's say, sturdy and reliable and known, let's say. So that's where we kind of knew from a tech scouting activity where we wanted to head. And then we eventually honed in, narrowed down to focus on manufacturing, because that was the market that demonstrated the most need of a solution in a brief time, so a brief time to market, that was rooted in moving stuff.
All right.
Okay. But then we understood that it wasn't only important to move things efficiently. There are already a lot of robotic solutions that do that, and they're very well known in the framework of manufacturing automation. It had to be done in a very flexible manner. There were no solutions for flexible mobility. And this was especially pertinent and meaningful from a business perspective in high mix, low volume contexts. So if you look at production, you can you can construct, you can produce millions of pieces of just one thing, or just maybe n amounts of mass-produced objects. But there's a whole aspect of manufacturing that is worked in small batches of highly different, very personalized for the end client production. And so automation in that sense doesn't work quite as well, because the processes are always different. And these processes are very also human-driven. The people managing these types of productions are still very valuable. So a mobile black box wasn't going to be, really hitting the need of creating a solution that could be used by the operators to move things in a flexible manner. That's also when it hit us that we had to really rethink collaboration. And especially in B2B, where the stress is very high. So as a shop floor worker, my KPI, my performance, my continuation in working depends on a solution that's very tricky to manage.
Okay. I'm very curious about this part of the collaboration, actually, because it's one of the areas of research that we are undertaking in Lab Coexist. And I would like, before arriving to more technicals or more details about the interaction itself of the robot, what is the intention or the purpose behind? Okay, you already said a little bit, but I would like for you to deep dive a little bit more in detail about the kind of collaboration in what sense with the worker, and how supportive the robot or node is in this context, actually.
Okay. I think this question can be answered in different ways. So I think I'm going to say one thing, and then the counterpart will also, because we created a team that was a hybrid design team.
All right.
Because we understood that collaboration is complex and really needs the attention of different disciplines. So the first thing we did is we invested, of course, in a strategic design manner, from a service design and user research manner, and then from a psychological and with a focus really on understanding the impact on mental models for the workers. So that's the first thing that we did in order to try to understand and demystify or decodify collaboration. But from a strategic and business perspective, we understood that we had to nail collaboration in order to create a solution that was adopted by the workforce. Because we could invent the greatest robotic platform, but ultimately, if it didn't instill trust and it didn't foster continuous and day-to-day adoption, it wouldn't even get switched on by the workers. And they would be the first ones possibly putting at risk the investment made by their key decision makers. And we didn't want that. We immediately saw that there was the potential risk of people not wanting to explore these type of solutions, not wanting to adopt them for fear of being possibly either displaced or of not being up to speed with technology and not knowing how to manage it. You know, we were seeing people as young as 16 all the way up to 60, 70. Yeah. And so that's the challenge, and that's why we adopted a multidisciplinary approach. So,
if I can say
sure.
something, that's why we decided.
You have to.
Oh, sorry. That's why co-design was a huge part of our process, and because our goal was to design for people, but also with people, to design a product that can really be helpful for real users like operators. And so this was the main part of the development process of Node. And we collaborated with Federico, and because we think that social attributes are very helpful, important to design a product that can be friendly, and that people can interact with without any barriers, without any problems, even people like Sarah said before. And so we collaborate with Federico, and with him we developed a robot personality, for example, and we set up a sort of elements, social elements like eyes, lights, and that can be helpful for the acceptability of Node, of the robot.
So I think I'm going to pass the word to you, but before doing that, I think one of the things that I think it's very cool about you is the fact that you are in the collaboration paradigm and not the displacement or replacement paradigm of robotics, and we're going to take that afterwards. You take the conversation from here?
Let's say we have been talking a lot on how your focus as a company has always been the collaboration, the interaction with the user, and the design-driven approach that is not really common in the robotic industry, right? Because maybe until now we are seeing a shift, probably, but robotics is coming out from research, from academia, and having this, I will say also courage and opportunity to start with this focus of design is very interesting. So we are very interested also on exploring the human robot interaction approach that you have. What were the research of HRI that focused your work when you started the process?
Thank you. I'm going to go with the wrench. So, I mean, there's been, as Sarah was saying, there's been a lot of field research. So starting from the beginning, understanding what is the use case of the robot, and once that was defined and selected, that's when I actually came on board to support and guide the human-robot interaction design phase. So at that point, we went back to some factories and to some industries to check the field, how does it work, even stuff like informal knowledge sharing, so posted, placed around the workplace, because these were all parts of what we wanted to analyze and discover. So the gaps within the current process of how things are done there and how people relate to each other even. So we conducted also interviews with the people from the workforce, observed how they worked in a standard day, have them explain how do they check the quality of the products that they do, how do they move them from one place to another to, again, understand where the product that we didn't know which kind of shape was going to have at that point, like, would fit in. So again, the whole design and research phase was key to understanding what is the problem to solve, so framing. After that, once that was defined, we moved into, okay, we know what people need, and we didn't do really personas. We did more like technical profiles of the people that were working. So you have the person that does quality check, the person that is a manager, so everyone with their own goals, needs, problems.
Yeah.
Based on these two sets of information, field research and kind of technical profiles to consider, we started to work on, for example, defining what the personality of the robot would be and doing a benchmark of what products and experiences that involve robotics that currently exist could actually be useful in our case. So, for example, in the benchmark, we focused in industry-related fields, but almost half of it were actually from social robotics or home robotics, which are the most advanced in terms of how to create a relationship because they absolutely do not have a utilitarian focus. So since our goal was to mix the two parts, we didn't want just a car that will move around and do the job, but we wanted something that had a social presence that could allow you to create a social connection and a collaboration, like even get into build empathy with this thing that will work with you. So doing this benchmark, we highlighted a lot of good practices and bad practices that we want to bring into our product. We discovered many things like the importance of gaze to communicate intention, emotion, to allow users and the people around to anticipate what your actions would be. We discovered a lot about the use of lights, movements, for example, that wheels, for example, and screens that moves is not just there to drive around, but it could be used to convey emotions. You have the wheels, you can wiggle them around when a task is completed to communicate a positive feedback, for example. There's many things that you can do. We conducted academic research, let's say, through literature, papers. There's many papers that already analyze and understand how the dynamic aspect of lights can communicate different meanings in robotics. And so this body of knowledge went into designing the personality of the robot. So mostly we focused around three aspects: relational, emotional, and conditional. Relational is what we consider to be which role does the robot have in your relation with it and with the product ecosystem. Because again, something to remember in robotics is that the robot is a touch point. Is not the service. The service is Alto's service. Then there is the robot. There is the web app. There is many things that could go on around it.
Yeah.
So at that point, like, how does it make you feel? We work with social roles. So for Alto, for example, we discovered that through a workshop that what we wanted the robot to incarnate was sort of the feeling of working with a postman or a waiter. Okay. That anticipates your needs, comes to you, brings you the fork when you need to change, or takes out your plate without being invasive into the relationship, without having to acknowledge its own presence. And this is a very, very key point into what the personality of Node is. The emotional side is which kind of emotions you want to feel relating with it or you don't want to feel. And the conditional, that to me was one of the most fun parts, is how does the robot behave in certain conditions. So for example, one of the metaphors that we used is as people behave in their most honest way when they're in a critical situation, an unexpected situation that they couldn't plan for, how would Node react if it was in a very positive situation or a very negative situation? And that informed which kind of personality and feeling we wanted the robot actually to give us.
Okay.
And after this, we actually moved, it's not related to the research part, but we moved into designing then what the actual interaction guidelines would be, how to use gaze, the fact that it doesn't have a mouth. Yeah. For example, we decided it because we didn't want to overpromise on intelligence. And again, since it is a companion that is not the center of attention, but it's a supporter. It has a supporter role. Why does it have to speak to you?
Okay.
Also, the fact that the screen and the eyes are on different things. We saw from cases in benchmark where the eyes are on the screen that people feel uncomfortable. We're going there poking the eyes of the robot.
Okay.
So these are all arrangements that you take and guidelines that we created to be the core of what Node would be. Because again, at that point, it didn't have a shape still.
Yeah.
So this is the process. We designed what had to be the core focus of interaction of the robot before the robot even existed, because that informed what the physical shape would be.
Okay.
And sort of last part that we followed is how do these whole behaviors actually take shape into what we call design patterns. So you have the different behaviors of the robot, like turning on. Turning on is made of actually switching on, then greeting the person, and showing that it is available to interact. So these three elements is what we call the interaction patterns. And they're made even from the detail of how many milliseconds the gaze has to look at that side, and then turn, and then do other stuff, for example.
Okay. On that point, I understand that Node is not completely autonomous, right? It has some autonomy, but is not autonomous. So you guys work with artificial agency. How was that process, and where do you guys decide which tasks were okay to leave to the robot to do alone, which others needs the input to the users?
Okay, so we're talking about a mobile robot, and we talked about how we mapped a multitude of use cases, and then through the design-driven approach, i.e., we built different prototypes, so essentially shop floor people could show us how they would use it whilst we didn't have an actual robot ready, really helped us understand what needed to be autonomous and what did not need to be autonomous. By the way, we don't have an arm, so that also simplified. One, our go-to-market, our time to market, and two, also this aspect of autonomy. And what the users told us was that they were fine in themselves setting the missions and choosing when the robot was to go and come back. Go where, for how long, do what, with whom. They really told us what they needed essentially from the robot. And so that is how we then built its autonomous level.
Okay.
Now, it's not easy then to, from a technical perspective, craft a robot that can move autonomously in the environment, also keeping into account that it had to be safe and so certified. We of course needed to certify our robot. So we then of course followed up with the regulation, the norms that help guide the behaviors, velocity, for example, distances, etc. So we also had that aspect that helped us define the autonomy of the robot. As we were discussing before, it wasn't important just to move. We were seeing a lot of patterns of people sharing information and tacit knowledge that was then not being codified. So if we had gone with a traditional autonomous robot, we would have missed a lot, an opportunity of collecting meaningful data for those micro movements. And so we asked them. We had an activity where they were compiling Post-its. So everything that they were talking and writing on papers and yelling across production, we had them write it down. And that was all not codified by traditional manufacturing software. And then we had them input it, quote unquote, this was all done paper and pen, in the screen of the robot.
Okay.
And then we had the business managers, the team leaders, warehouse manufacturer, for example, managers, say, do you need this information, or is it just at shop floor level? And they were like, wow, okay, I could, from this information, improve my processes. Because at the moment we're not detecting this information. What if we were to have this information? And this is another level of quote-unquote autonomy. We could have collected all the information and proposed improvements or enforced improvements, prescribed to the user the best mission. But they didn't want that. They weren't ready yet. So we have it in our backlog, and our first version will just be 3 dashboards where users will be able to see some scores that add insights on their level of use of the robot, optimization of the robot per se. And then they can download the information if they want, and then possibly develop new missions, optimized missions. But it's and this might seem counterintuitive or counterproductive. Well, why don't you just embed the robot in doing it for itself? But they weren't ready yet. So we chose to keep that as the second version, let's say.
Future development.
In that case, the operator chooses the mission on how to optimize it because they see the data and they choose to apply it.
I think one of the interesting things that you're talking about is that usually when we improve services or processes, we take the formal part of those processes and we say, how can we improve? And we do qualitative research and so on. One of the very interesting parts that you're saying is that you focus on the probably informal steps or the micro moments that probably are not formalized in a paper, but undertake the part of the connects to the process of everyday workers, and probably there is a huge percentage of improvement of what they need to do. So this is how you are impacting somehow their life and trying to say, instead of me saying, hey Ciro, hey Giada, or hey Federico, somehow already that is into the machine or the robot, and the robot knows what to do. So it's another level somehow.
One would think it's, as you were saying, micro moments. Well, what is the business impact of a micro moment? But if you start adding them up, it turns out that at the end of the day, a line facilitator of a manufacturing plant, if its time is saved by not walking around looking for missing information, bringing missing information or tools, or intervening when there's a stoppage at line level, they actually free up 4 hours almost per day of valuable time that they can dedicate to activities that also gratify them the most. But ultimately, they were the first ones saying, yeah, but if I want to go have a chat, can I still go? And of course we were saying, of course you can. And in fact, we added into the mission the fact that they could personalize also social missions, like saying happy birthday to someone, or maybe codifying information just by typing. So they can also say, hey, how are you doing?
Okay.
Which they felt allowed them to be more themselves through the robot, which we thought was really interesting.
Yeah.
So essentially, when we started putting together all the reasons for micro stoppages, we actually understood that we already had 3 pretty interesting business cases. And I'll give you an example. When Giada and I were doing research, we were curious to quantify the times in which these welders were stopping. So we counted, just keeping a random piece of paper, we counted the times that they stopped. Then we asked them, why did you stop? we monitored how long they stopped for, and then who was involved in resolving that problem. And it turned out that we were 50 times a day that they were stopping. And then for each time, they stopped for a minimum of 5 minutes, but up to 15, 20 minutes of 2 people. And you multiply this, it had, a really sound and significant business case. We thought, okay, that's interesting. So that also helped us through the 3 different use cases, qualify and focus on the flexibility.
All right. Okay.
All of the information that we gather from this discover activity, we then had to traduce in product requirements. So we gather all the information, we traduce in product requirements that then we applied on the prototype that we built to test all of the elements of Node and all of the requirements that we set up. And
Perfect. Yeah, because I actually wanted to jump on that point. Today we have seen many prototypes. I know that you guys have been creating prototypes since many versions, interactions, and so on. So I was curious to know what was this process of the prototype creations, how did they evolve, and what were like the main points that you wanted to test with each prototype, with each interactions. And before you answer, also would be nice to have like a point of reflection on when the industrial design started also to became a focus point for your team, and what was the importance of the aesthetic form factor for that.
Okay. So, like you said, we worked on and we built different types of prototypes, and with different materials based on the phase of the development process. And we use them to test all of the functionalities of the elements of Node, of the product. And for example, at first, we built a cardboard prototype. So we start from a cardboard prototype. And with that, we could design the concept of Node. So how Node could be, what Node could do, what elements Node could have. And that part was really important for us to understand what elements could be important to design a product that can be helpful, collaborative with operator.
Sorry, that first cardboard prototype was after the requirement settings and all this first market thing, or like in parallel?
I can in parallel. At first, we built the first prototype, cardboard prototype. Then step by step, we gather feedback. We traduce them in requirements. We applied these requirements on the other prototypes that we built after the first one. And step by step, with all of these prototypes and together with the users, we tested all of the elements from the handle, so from the physical elements like the handle to the digital elements like the user interface.
Right. And the technology, we haven't talked about the technology, like making the radar, LiDAR. I think the robot has LiDARs, sensors, cameras, all that features that suppose were of course needed to be tested and developed. So that part entered after the first use cases and priorities were set, I suppose. So.
Yeah, so it was very important for us to mitigate the risk of sending towards R&D requirements that weren't in some shape or form mature. because hardware is hard and very expensive. So the tricky part at the beginning, and it was tough for everyone, was to be doing discovery, eliciting needs, translating them into insights, slowly maturing them into requirements, but not having an actual specification to leave off to R&D, who are engineers who then need to translate that into metal, electronics, purchasing and testing of very expensive sensors and so forth. So that was a really tricky part to keep balanced. We were very lucky to have R&D, for example, come with us to some of the research, but it was tricky to align their speed and their level of detail with our speed and our level of detail. But that is the case for any hardware company. But it was important to take the time before having R&D launch itself in the unknown, quote unquote, so that we could perimeter the risk of investing in hardware, effort, and so forth that didn't have a good product market fit.
Right.
So once we had a pretty good idea of the form factor, roughly how big, roughly how tall, roughly how big the screen, from a personality perspective, how tall should the robot be so that it gives the sense of control to the human? What type of haptic handle roughly should we think of? The tummy, was it supposed to be rigid? With what kind of shelves? How many shelves? Once we had that kind of thoughts pretty much sketched, unfortunately sketched, we then started working on the industrial design.
Okay.
And that also isn't a given. So not a lot of robotic companies or hardware companies invest in trying to make the solution that they're going to be producing also aesthetically pleasing.
Yeah.
But we understood that the more curated the robot was, the more, the more quote unquote elegant it was, the more trustworthy and the more of quality it was perceived as. Yeah. It's as if, you go to your workplace and you dress in a specific manner. Users were expecting it because they felt it intelligent, that it also looked intelligent from a color, material, and finishing perspective. So we invested in collaborating with an industrial design studio to codify that aspect as well.
Okay.
We then measured it in a quantitative study, and we saw that it made a difference. It elevated the perception of the robot as a teammate as well. It had an impact, which we weren't expecting.
Perfect. I suppose having the R&D team with you guys in the field at the beginning is a big help, because sometimes for R&D it's difficult to wrap their mind on all the work that you need to do beforehand, before jumping into the technical solutions that they are more comfortable with. So I suppose having them also being part of that process was something important also. Talking about the metrics, I suppose you were talking about the testing protocol of RoSAS, Robotic Social Attribute Scale, that you guys implement to understand how the robot was perceived, right? Maybe we can talk about that part.
Yeah, sure. So there's several tools that have been designed in robotics. There are not that many because it's not a new field, but the tools to use, they're standardized, like RoSAS, which is a standardized test between different countries is. So at a certain point, we picked that to conduct a research that focused on understanding how did the social aspects of the robot actually land when getting into the field, when interacting with people. So the RoSAS, for example, measures on warmth, competence, and discomfort that you have in the interaction. So it was a great way to measure where we were in building trust, in having the user understand how much competence the robot had in supporting the tasks that they had, and how would they actually feel. Like during the research, there were some fun facts that came around, like people giving names to the robot itself. So you, at a certain point, to start measure and track other things. RoSAS was one of the tools used, but observation and a standard design and research protocol was still there as well.
All right. How did you guys build and measure the trust with the users apart from RoSAS? I mean, how did you jump that let's say gap of the workers being able to trust that there is going to be this piece of technology there that is not there to steal their jobs, but actually to be a teammate and to collaborate with them and make their life easier?
Always through a human-centered approach. So we actually were lucky enough to have the opportunity to deploy our robot prototypes in 12 different POCs, meaning we brought the robot, different forms, let's say, different prototypes, and we allowed users to adopt them in their workflow. And when we understood, we had focused, as we were saying, on 3 core use cases that were, from a business perspective, the most transversal to the world of manufacturing, high mix, low volume. When we started deploying our robot in the proof of concepts and users were giving us new use cases, that is when we thought, aha, okay, something is working here. On the one hand, they trust it. So they were saying hi to it every morning. They were saying goodbye every day, for example, at the end of their shift. And we thought that was curious. They dressed it up, for example.
Really?
Yeah, because it reminded them of Sheldon in The Big Bang Theory. So they brought a scarf the day after.
Okay.
But when they were suggesting to us, today I want to go and ramp up a machine. Can I do that? Well, how would you do it? Let's go for it, So they were the ones telling us how they would have wanted to use it.
Okay.
That's how we found out that it was necessary to have a work surface. We hadn't foreseen the top of the robot as a work surface. Oh. But, for example, in line ramp up or when you're changing the mold to a machine, you're using the surface to put things on top. And that's how we redesigned that top part so that they could use it as a proper quote unquote bench, let's say. So that is when it hit us that we were getting to a true form of collaboration, when they were the ones proposing us the use cases, and we measured up to like 23, 24 use cases.
Oh, okay.
Additionally to the ones that we had, focused on at the beginning.
Adding to this, respect to the topic of how we actually built the trust that then we measured. For example, one of the main aspects is making the robot readable and understanding and allowing people that would observe it, even from afar, to understand its intentions. Yeah. So again, the importance of gaze, like looking towards the end of a turn that it is taking so that you understand it's going there and not directly in front, and then you don't know when the turn is going to stop or whatever. Even stuff like not optimizing the movement. So you have robots that move in a very optimized way. So you get to the obstacle, you turn, you go around. No, you know that there's an obstacle there, you turn around like a person would. Because also that allows to manage expectations. I don't get against you 2 meters away and then I suddenly stop and I move away. There's principles like if you see a person that's coming towards you from the other side, at least 5 meters apart, move to a parallel route. Okay. Do not go toward it, because then it becomes confrontational.
Yeah.
Like this kind of actions have meaning. If you see someone that comes towards you, you will feel threatened. Yeah. So building trust meant especially to avoid all the things that would make you not understand what it wanted to tell you, and make sure that what it wanted to tell you was not a negative thing, but it was a positive one, and also allow it to be readable easily. For example, you have all the lights and different lighting on the robot. The bottom ones are for movement and giving direction and showing what's front and what's back. The medium level ones are status based. The top one is expressions. So there's a taxonomy that is clearly understandable, clearly used.
Okay.
Stuff like the front light is white and the back light is red. Why? Because we all have the experience that vehicles work like that way. So that improves how readable and easy to use it is at the end of the day.
Perfect. Just one final question on my part, then we jump on marine section again. I was just curious, did you guys have in plan the training on employees? I mean, how is going to be the implementations of Node? Is self-sufficient, or what are you guys preparing for that?
So we, one of the things that we saw in our first discovery phase was that, as we said before, there are already a lot of solutions that are fully autonomous and that move things in manufacturing, and they're very consolidated platforms. But one of the things that we were getting back from our users were that these were very inflexible solutions. Once you deploy them on maybe 1 or 2 or 3 specific routes, it's very difficult to reprogram them autonomously. So you always have a system integrator or maybe R&D that goes to try and remap the space and reconfigure the missions. And we felt this as a barrier to enter for a lot of companies that have these flexible processes, but also maybe not the economic breadth of investing in a full-blown automation process. Wow. Maybe they don't even want to review their entire manufacturing processes to accommodate 1 or 2 mobile robots. So we really took this and we said, okay, can we make our robot plug and play? This aspect, we, from a product perspective, worked so much with R&D. This was one of the key points that really helped us work as one full-blown team. Not that we don't today, but as I was saying, R&D and product usually go at different velocities. But in that case, we were really working side by side. So our challenge was, how do we make this robot plug and play? It means that the shop floor worker, without any training, needs to turn it on and be guided by the robot into setting it up. So with Jada, we worked a lot on the first user experience, the unboxing of the robot. And we leveraged that to build trust. Okay. So we tell people what it is. We don't take for granted that sales or their team leader has explained to them anything. So we tell them and onboard them as if they know nothing. So in 5 minutes, they run through the whole first user experience where they understand what the robot is. They understand the core technological aspects. So they understand that the robot doesn't see them, monitor them. It's not there to steal their job, but in a very informal and dogmatic way, let's say. And then it's the user that maps the working space. What do you do when you get a new colleague? You show them around. You say, this is where the toilet is, this is where the coffee, this is where we get coffee. And we wanted to mimic that. Okay. And so R&D gave us a great idea. Why don't we use gesture recognition so that the human can command, quote unquote, the robot to follow him or her? And that could be used to map the space, for example.
Right.
And that was brilliant. And we hacked it together at the beginning with existing software and algorithms. And the effect that it had on people was, I can do this. Okay. I'm in command, for example. And then that's when we started adding aspects of touch. We reinforced this with Giada. We understood that they wanted to touch it, but they were a bit scared. Well, why don't we foster it?
Right.
So, for example, in inventory, or when you want to scoot the robot to the side because you want it really close to the place where you're working, having a haptic handle was really useful. So that is how we also try to factor in technology, this idea of trust and collaboration, but also really putting the shop floor worker in complete control so that they could dominate and fully own the solution. And that really, really helped.
Perfect.
We also focused our attention on developing documents, contents, guides that can explain to the user how Node can use. Like Sarah said, we worked a lot on the FUCS, on the first user experience. But yeah, then we worked also on other contents, videos or guides that can explain how you can use Node alone without any help.
Perfect.
I think the part that actually the final worker, so the final user, is the one who unboxes the robot. It's not like one day arrive to the workplace and it finds the robot there. It's a huge kind of perception, expectation kind of way of how to familiarize with an artifact that somehow is going to be helpful, but you need to understand it a little bit. So I think this is something very interesting for us. It's part of the product experience. We're talking about experience.
And you have like a sponsor in the floor shop that is going to be like the person who unlocks the robot. He's going to be like
your robot somehow.
That's really.
But this is important because right now, what we saw, for example, with sales. So we talked a lot about the role with R&D that was crucial. But let's not even forget sales. So, for example, we have a sales team who are the ones ultimately bringing the robot to market. And what they were telling us is it would be really useful if we can have material content to leave the company that we just sold the robot to. And so from a service design perspective, we have our service blueprint from the moment you turn on Node to the moment you have an issue and problem and you need to do maintenance and service. We need to extend that. So we then pulled the service blueprint all the way to cover also waiting for Node. Yeah. So what happens in the time, because time to market is about, a bit less than 2 months. What happens in, how do you manage expectations in those 2 months? Yeah. That is why we did, Giada did a great deal of work on constructing the tutorials so that the shop floor assistant could be independent in managing, a low level, cases of the robot maybe having issues or troubleshooting, etc. But then we understood that a lot of that material, plus the material used for the first user experience, could help people understand and really appreciate Node before its arrival.
Okay.
And it could also be used as quote-unquote sales material, as a way of fostering the conversation. And that is how we developed with sales a way in which to understand how to select an ambassador. Because on the one hand, you could have the line facilitator, but not everyone might be as inclined to. So they have a little questionnaire that they can administer to the company that they sold the robot to qualify, if desired, not forced, of course, the right person.
Okay, so we're arriving almost at the end, but not the end actually. and I'm something that reminded in my head from what you said. It was, the human in the loop, human-centered design, the people that you interacted to design Node somehow. I have one curiosity. The average of age of those people that you co-design with, and where is the expecting target of the people who work in these places, and how you actually, in this sense, are projecting what inclusion means, and what actually, if we can talk a little bit about principle or ethical principles regarding all these targets and workspaces that Node is going to perform.
So we, as we were saying, we managed to have 12 POCs and 3 pilots. So we involved a lot of different people in our let's say co-design and user testing process. And we saw at shop floor level everyone from the age of 16 to 70 plus. And that was an important input in our design process. We understood that we really had to design so that everyone, quote unquote, could be autonomous in using our robot. So how did this impact our design process? For example, we understood that we had to generalize the way in which we structured the missions of the robot. One, we had to be as flexible as possible for any kind of mission. Rapid, multi-destination, so forth. And 2, we also had to make it so that anyone could, through minimum clicks possible, create his or her own mission.
Okay.
And that's how we tried to be as, quote-unquote, accessible as possible. The design studio that helped us also with the UX, of course, tested it from a inclusive design point of view. For example, indoor, outdoor, also from an ergonomical standpoint, with gloves, without gloves, except left hand, a right hand, etc. We, of course, did those procedures. But our main attention, to be very honest, was to create UX patterns that were as general as possible for people who were digital natives or who had difficulty using their mobile phones.
Who was the person who wanted to put the scarf on the robot? What age that person had? I'm curious.
Okay, so he was actually, we were in a company that we're very fond of, and he was the warehouse manager.
Okay.
A very private person, but when it hit him that it looked like Sheldon, he wanted it parked in his office at night. So when we charged him, and he was the one, I would say roughly 50.
Yeah.
Yeah.
No. Okay.
And he was a warehouse manager, not, a young.
Yeah.
Yeah.
No, I think I really admire one of the things is how democratic somehow your design is, in the terms that the robot has its own functionalities, because it's not only one, it has different kind of functionalities. But the fact that the human input is important in all the stages, I think it's one of the things that we're not seeing right now, because we are right now living in a moment of fully automation. And this is how I'm going to, link to the next question, actually, of, you are producing or designing something where the human somehow, or the person, is at the center still. Big tech, let's say, what we see every day in the news is trying to force or push towards a little bit automation and replacement of humans. And this is actually when we listen to, some people of coming from that market say, soon enough, in 5 years, we're going to have the one-person company. That somehow is challenging, it creates expectations, but in some other parts it's like, do we want actually that? And one of the things is, how do you as individuals, not only as Alto, but I would like this more from your personal point of view, foresee a little bit the coexistence between humans and machines in the near future? I already know a little bit what is a little bit your inclination, but I would like to know, what do you imagine from here to 5 years, either to 50 years? What could be that coexistence that we should achieve with machines? Go.
Mine is a very personal perspective. What I would like to see is robots being robots and humans being humans. I think that there's a part of intelligence that belongs and differentiates humans from a consciousness point of view, ethical, spiritual, and so forth. In those realms, humans possibly need to evolve in order to compete with the velocity at which tech is bringing new forms of intelligence that are partial to human, but are not, for me, all-encompassing. That's why humans should be humans and robots and automation should be relegated to that. As a designer, it's the responsibility, I think, of who deploys these solutions to understand how to create that space for each to coexist. It's a personal, ethical, moral principle that one should apply. I understand that this is very difficult from an agentive AI perspective because a lot of quote-unquote reasoning is still unknown. And even though you might provide positive inputs and structure algorithms in a constructive manner, the logic might bring the solution, either AI or a full-blown embodied AI robot, into a direction that is completely the opposite. So I know there's a lot of complexity in that, and I'm not a technical person, but I would say that from a design perspective, it should be codified from the beginning. There should be the intentionality of creating a coexistence relationship. We tried to do it with Node. There are a million other ways it could be done, I'm sure, given the context. But through listening to the user and really trying to balance the two parts in the relationship, I would like for there to be a healthy coexistence. If you also factor, quote unquote, the planet, which should also be another aspect, we all should live in symbiosity. You know, there's other thinking also towards that. So, for example, what we tried to do was design our robot so that it could be easy to maintain, easy to recondition the parts. From a material point of view, we are reusing a lot of recycled materials, but that should also be factored in.
Complex question with a lot of sides to it. So in terms of how does it fit within the collaboration, for sure, from my perspective, what was done by Alto and in Node was exactly at the beginning to understand which were the gaps in the experience of people. So it wasn't a study of the production process and how the production process could be optimized, because that would lead to automation. Instead, it was the study of the production process made of the people that work in the company and how that could be optimized. So that's why Node has the shape that it has, doesn't have an anthropomorphic shape other than the eyes, doesn't have an arm. Like, it's made for a very specific task to support the people that work there. And this is a very relevant point to make when discussing about the insurgent wave now of humanoid robots. Humanoid robots are usually made, like even psychologically when you perceive it, is as another person. So as a potential substitute of what you do. Is less about improving the way things are with the people that are there, but instead actually changing who does those things. And this is a huge problem in my perspective related to the future, because if we start having like thousands of robots around us, then what is our value if we assume that they can do exactly the same in the same way. So there also has to be a perspective of protecting the role of people. And getting to the last part of the question of how do I see the future of coexistence and what intelligence in all of this is. Again, humanoid robots have every robot has something called stance. Like there's a higher stance, it is your equal or even someone superior to you, or it's someone below you. Like a little tiny robot is someone below you. You will feel more in charge, you will feel that you're the one responsible for things. Humanoid robots have a very high stance, so we'll be starting filling our environment with things that we tend to consider as equals or on a higher level and potentially as a threat as well. Not because they could actually be, but because psychologically we feel there's all these machines around us. So at that point, really, to me, going towards the direction of robots that are even smaller in shape, that do what they're supposed to do in a specific context, allow us to avoid that we start building relationship mostly with robots, because at a certain point there will be the elements that are mostly around us. So even avoiding what could be called social degradation. People finding more easy to build relationships because you ask a question and they just do it. There's no discussion, there's no point of view different than yours mostly, than the one of the large language model that's behind it, for example. And so we need to also protect our ability to create relationship with people. We're already seen not managing this, what brings with social media, for example. You think the life of others, checking out their pictures is better than yours, like a higher level of depression in people that have a dependency on it. This is exactly what I expect to happen if we don't manage the way we build the relationship with robots around us, especially if they have a humanoid shape.
Thank you, Federico.
I agree with Sarah, and I think that attention has to be focused on creating a balanced relationship between human and robots. And talking about future, I think that collaboration could be a keyword to the future of robot developments and in all of the variety of contexts.
I have another question. Does the meaning of intelligence, as you have learned or acknowledged it in your growth somehow as humans, has changed since you were designing or creating Node somehow? That meaning it's very wide and broad, this question, of course, but does it somehow, that concept of intelligence has mutated or has evolved because, what you've done somehow?
There was a moment in time in Node's development that we were imagining it as a Christmas tree with like a gazillion sensors and trying to reflect on multi-nodal interaction. So the fact that Node could pick up data from its context and from its interactions, and then in some shape or form suggest or autonomously decide things. And then through the design research, we understood that this was putting people off and it was actually being perceived as distancing. But that is a moment in which I had to question what was Node's role and what was the role of this type of technology in the relationship to humans. And as a designer, the one key aspect is empathy. So it became very clear. If I'm talking to my collaborator teammate about an issue that I'm having, I can have all the data that I want. I can maybe have that person pretend to listen to me. But it's the true understanding and the consciousness of what it is, the nature of what I'm saying is, that makes the other person intelligent, emotionally intelligent or not. So that is when we understood that you could have 1 million sensors, possibly, and you could possibly even do facial recognition. Of course, we don't do that, and we chose not to do so. But there's still a gap there. There's still something there that, at the moment, plastics and wiring and PCBs can't do.
Okay. Do you want to add something? Yeah.
Thanks. I totally agree with that. I would add also that I consider a robot to be, I associate intelligence with a robot when it is intuitive in the sense that it can understand what my intentions are. So in that case, we go towards more agentive point of view in the sense that it understands your goal and acts on it. But it doesn't have an explicit thing. I don't have to tell it what I want to do. The best solution to me will be the kind of relationship that, for example, we build with the dogs. You look at the door, they understand that you're about to go out. That is the intuition that we need in robotics to avoid to have to say explicitly in every interaction what we want. It needs to be able to understand what it is. Then, of course, you need to do it when you're ready to do it on a machine level. Because if you do it wrong, you destroy trust the moment it gets it wrong. And once you do that, it's very difficult to recover. So it's way better to avoid at all agency as long as you're not ready to be there. And in general, even with artificial intelligence in general, I don't think we're there yet.
In that, can I connect to the fact of what kind of challenges or risk do you foresee with all the development that we are seeing right now, fully automation, but also with the high-speed development of Gen AI and Agentic AI itself connected to the robotics? What kind of risk of challenges can you foresee in this rapid scenario that we're living right now?
Okay, I'm gonna go. So I can follow the previous one. Robotic design is interaction design at its highest, because you're talking about something that has a social presence in the environment around you.
No.
And that is way more than what software AIs, for example, have. So once we actually get to embodied AIs, that is very heavy to manage. So I do agree. There's a lot of development that's going on. There's AIs on one side with their logics, with large language models behind it. There's robots that starts to include that as a translation level in between to code between what you say, what you want, and what is translated into a robotic operative system and machine language. I don't have the answer on how to solve this, but the speed at which we're approaching it is alarming, because we know the technology is going exponentially faster. So in general, any implementation, think about it not twice, 3 times, because you do not know how that will work. Also, a lot of our experimentations are with one robot on the road that delivers an object. Yes, but you need to get into the perspective of future design, speculative design, where what happens when you have 100 of those on the same road? Yeah. That is the design problem that we need to face now, to design the robots now that will be there tomorrow.
Yeah, actually, we are getting into a point where we see how some different type of agentic AI are behaving very different. That I don't want to enter too much in detail, but we are seeing right now how, like, the model of OpenAI versus the model of Grok, they are behaving in a way that is, frankly, from my point of view, quite alarming. But it seems like we are moving so fast because there is this, rat race or who gets there first. And these guardrails that you should be implementing seems like are being just ignored. And it also seems like jumping from the only software to the embodiment of these models. It seems like it's just right next to the corner. Probably we are talking about 10 years, but for me, 10 years is just right there, right? It just seems sometimes a bit like a big risk, just to get there first. How many things you are going to just ignore, and what could go wrong could have a big impact.
Less is more. So in these moments, that's what I try to practice on myself or with my kids and my family. When things get very out of hand, stop, and as Federico was saying, think. What do I mean? Select the use cases very carefully. We don't have to necessarily apply robotics or agentic or embodied AI everywhere. Do we need it from a humanity perspective? Where? At the end of the day, it's like our compass, our human compass. Why? Why are we doing what we are doing? What are the values that you are embracing and applying? So I would select use cases absolutely very carefully and think of the consequences at a systemic planet level, 2 years, 5 years, 10 years, worst case and best case scenario. Because otherwise, as you were saying, the desire to prove that you've gotten there faster may mean that the consequences are dramatic, well beyond your local perimeter, your specific company or nation perimeter.
Yeah, I think that the risk is not only like a company that do a type of solution like that. It's like it's not only that their product launch doesn't work because they do some decisions in the process where maybe I launched this product that was maybe over-promising something and it doesn't work like that. For me, that is not a real risk. Like, okay, companies fail all the time, right? But the problem is that if many companies start launching these systems out in the market without having conscious safety implementations, then many things can go wrong. And that's where I am into the regulation part of where, at least in Europe, some time ago we were talking about implementing, and now who knows what is going to happen, but it's quite frightening where we are going to be. But
if we choose. At the end of the day, there are two levels of thinking. There's system 1 and system 2, and then there's system 0 that we're now developing, i.e. what happens when we start to delegate to forms, other forms than ourselves. But, we can decide what to activate, what type of thinking to activate in humans through the technological decisions we implement. We can choose.
Yeah, that awareness is not quite spread, though. I think very few were talking in the car while we were coming here about the awareness of understanding actually what another intelligence can actually do for you, or what can you both do in which way and what roles you should have in between. And I think there is not a complete awareness of many people of how this, and actually talking from the end consumer into the ones who probably are teaching those concepts and so on of artificial intelligence. So we have arrived to the end, to the end of this chapter. Thank you very much, Giada, Federico, and Sara. It was an amazing discussion. Thank you, Zero, for moderating with me, and I hope to see you very soon.
Thank you. Thank you, guys.
Thank you both.
Fatto bene? No.
No.